Welcome back to practical session of Vivekananda School, Jogiwala, Dehradun. In our previous session, we have discussed about the material required and the circuit diagram, and also we have done with the connections for finding the unknown resistance of a given wire and hence resistivity using meter bridge. Theory. Meter bridge is based on the principle of Wheatstone bridge. Here you can see the figure of a Wheatstone bridge where AB and BC are called the ratio arm and the known resistances P and Q are attached here. This R is also a known resistance which is connected in the arm AD, and the unknown resistance is connected, unknown resistance S is put in the arm DC, and a cell is connected, cell of EMF E is connected between arm A and C. Now the galvanometer you can see here is connected between the arm B and D, and if the galvanometer shows no deflection, that is the balance condition of the Wheatstone bridge, and in that case P upon Q is equals to R upon S, and this way we can find the unknown resistance, that is S is equal to, here in this, from this equation, S is equal to RQ over P. Likewise here also you can see this is a known resistance to us, the resistance which we will be taking out from the resistance box, and this is the unknown resistance, right? And the galvanometer here also is connected between B and D. You can see here this was B and D, galvanometer is here between B and D. When the jockey was slided over the meter bridge wire, we'll get a balancing length where the galvanometer will show null deflection. That is the point where the meter bridge is balanced. Let's say L is the length where the galvanometer has shown null deflection. So if we say small r is the resistance per centimeter of the given wire, so the resistance of this length would be your LR, and the remaining resistance would be 100 minus LR. So we can calculate the resistance using the formula X is equal to 100 minus L over L into R, where R is the known resistance placed in the left gap and unknown resistance X in the right gap of the meter bridge. L centimeter is the length of the meter bridge wire from zero end up to the balance point. Now since we have to find the specific resistance also, so the formula for rho is pi d square, where d is the diameter, into x. X is the unknown resistance which we would be calculating from the observation table, upon 4 by L. Now we are done with the circuit arrangement. We will see whether the circuit arrangement is right. We will put the key in the plug, this one-way key, we'll put it in the plug, we'll put on the switch so that battery eliminator starts working, and we will see when we will put the jockey across one end of the wire, one end of this meter bridge, and then we will take this jockey and check it here. The galvanometer should be showing deflection across both the sides. Then we will say if the circuit arrangement is right. It should show deflection towards both the sides, right? Let's see here. Now you will be checking. You just focus on the galvanometer. I'm sliding the jockey. I'm keeping the jockey to the extreme left. Now you see, 1 minute. Okay. Now you see the galvanometer has shown deflection towards the left side. Again, I'll take the jockey and I'll slide it over to the extreme right, and you can see the deflection across the right side. So that means our circuit arrangement is right. And now we are ready to take the readings. Now we'll be proceeding towards how to take the readings. First, I'll explain you the steps, then I'll explain it with the help of a table. So what actually is the procedure? First, this is your resistance box. So you will take out the resistance from the resistance box. Let's say I have taken out this 2 ohm, this is 1 ohm, this is 2 ohm, this is 2 ohm. That means, or you say, let's take out a 7 ohm resistance. We'll put it back here. 7 ohm I want in the circuit. So this is 5, and 1, 2 I have taken out. So this is total of 7 ohm resistance. Now, same way I'll proceed. What I'll do, the rest of the arrangement will remain same as such, but I need to find the balancing length. Balancing length is the length where the galvanometer which will stop showing any deflection, right? So I'll slide. Now the resistance which I have taken out from the resistance box is 7 ohm. You can see the keys here. Now I'll find for the balancing length. So here, if I slide it, now you see, now I'm sliding it here. I'll put this on. You can see the length. Now the galvanometer is not showing deflection, deflection, deflection. So at point nearly 50, this is showing 55 point. So here at, you can see now the galvanometer has stopped showing the deflection, right? Now we'll check for the point where the galvanometer has stopped showing the deflection. That point is, see, that point is, let me show you from this side. Let me show you from this side. If you can see, this is 55.5. Can you see the reading? Okay, let me slide it. I'll show you through this. So this is 55.5, at which the galvanometer was showing 0 deflection. You can see here. So this is this point, this 55.5. I'll note down this length. Another length also I want, which is 100 minus L, which is coming out to be 44.5. You will see here that would be 44.5. Both the readings I will write down. And same ways, I'll check for some more values for the to add in the observation table. Now, like this, I'll be taking out, let's say, I want 10 ohm resistance to be taken out from the circuit. So I'll pick the resistances from here. I'll pick 10 ohm. So already I had 7 ohm. So 2 more, 5, 6, 7. This is 8, 9, and this is 10. So now I have picked up 10 ohm resistance, and similarly I'll slide the jockey over the meter bridge and check for the balancing length, that length, and 100 minus L. 100 minus L you can write down from here, and you will note down the reading similarly. Clear? Now we have the table for the measurement of resistance of the wire. So first is the serial number. Second, resistance from the resistance box. That will be denoted by R. These are the keys of given resistances which we are taking out from the resistance box. Third is balancing length, L equals to AB. This is the length where the galvanometer was showing null deflection. Length BC. This is equal to 100 minus L. 100 minus this L, and unknown resistance X equals to 100 minus L upon L into R. So R we will substitute from this table, 100 minus L we will substitute from here, and upon L. So like we have demonstrated for the first reading, I took out a 7 ohm resistance from the resistance box. So the balancing length came out at the point 55.5 centimeter. So the remaining length is 100 minus 55.5, that is 44.5. After substituting the given values in the above formula, the resistance was nearly coming out to be 5.61 ohm. Likewise, we'll take other observations also, 2 and 3. Then whatever observation we have taken, we'll take out the mean of those observations, and that we will represent with ohm. So this is the unknown resistance which is coming out through the procedure. Then we need to find the diameter also of the wire, as the aim of the experiment is to find the resistivity also. So for the diameter we need a screw gauge. The pitch of the screw gauge is 1 mm. Least count of the screw gauge is equal to pitch of the screw gauge upon number of division in circular scale. Pitch is 1 mm and the circular scale divisions are 100. So the least count is coming out to be 0.01 mm, or if we write it in centimeter, it is 0.001 centimeter. Zero error is nil. So table for the diameter of the wire, we'll be writing serial number, linear scale reading, that is x mm, circular scale division n, circular scale reading n into least count. This n multiplied with the least count, that is 0.01, and the diameter diameter equals to x, this linear scale reading plus circular scale reading into L least count, LC. So here, like you can see, it is 0 for the linear scale. Then for the circular scale division, it was 86. When we multiply it with least count, it is coming out to be 0.86 mm. And when we combine this linear scale reading plus circular scale reading, it was coming out to be 0.86 mm. Likewise, we will calculate the other observations also. At least minimum 3 observations we need to calculate the diameter, and hence we will find the mean diameter of the given wire. Therefore, the specific resistance can be calculated using the formula rho equals to x by d square upon 4l, where this is the unknown resistance and d is the diameter which we have just now calculated. These values we will substitute and we'll get the resistivity or the specific resistance of the given wire. So the unknown resistance of the given wire is found to be whatever value you are getting, that you will write here, and the specific resistance is this much ohm centimeter, right? Now the precaution which we have to take first is the connection should be neat, clean and tight. All the plugs in the resistance box should be keyed properly, otherwise that much resistance would be included in the circuit. Jockey should not be pressed on the bridge wire. Key should be closed only when we are taking the readings.